The two resistors, they are said to be in series if the same current flows across them. Okay, let the resistance this be R1, R2. Two conductors of some shape we don't know. The overall resistance of them is R1 and R2. So there's the EMF of cell you can call E. So a current I will flow. Where current enters, the end should be positive. Where it leaves, negative. Because we know according to electrostatic, the positive charge will flow from higher to lower potential. No? Similarly here, positive, negative. So the current I will pass through it. Then what is the potential drop? The drop across this potential difference will be V1 and this is V2. I want to replace this with an equivalent conductor so that the same current, when I connect across a cell, same cell, the same current should flow here. Then you can say this R is equivalent of these two. So from here, what you can write it as E equal to V1 plus V2. What is V1? V1 plus V2 equal to E. What is V1 from here? According to Ohm's law, IR1. This is IR2. Looking at this, what is E is equal to? Potential drop across that should be equal to I into R. So therefore, R1 plus R2. So this is the effective resistance of the cell. Let's come for other thing. So I want the potential drop across them. V1 should be equal to I into R. What is I? E by R. Further, R is what? R1 plus R2. This is called like a potential divider formula. Similarly, what is V2 is equal to I into R2. E by R, R2. E R2 by R1 plus R2. This is about the potential drop across individual resistors. The very important formula. These are called like a potential divider formula. Now, whatever the power dissipated, so P1, what you can write it as I square R1. P2, what you can write I square R2. And what is the total power generated? E into I. Any relation between them? How that power generated by cell should be related to power dissipated across the bulb. Say these resistors, in place of resistors, you can connect a bulb. Two bulbs are in series. So shall we write P equal, so first we'll equate P1 plus P2. I square R1 plus I square R2. So this should be I square R1 plus R2, no? What is R1 plus R2 is R. What is further? I into R. So what is I into R? It is E. So therefore, this should be equal to what? P. So P1 plus P2 should be equal to P. So what all power generated by a cell, what will happen to it? That should be equal to sum of power dissipated across the individual resistors. This is very important. Suppose say like you connect two bulbs. So what is the total power dissipated in the bulb? This should be equal to the total power generated by a cell. That's what is telling. So the power generated by cell should be equal to sum of power dissipated across individual resistors. The powers are additive. Shall I use word additive? The powers are additive. You have to just add up the powers that are dissipated in individual bulbs or the resistor. So in place of resistor, you can connect also bulb. I think this will be very much useful for you. So this is cell. Each bulb will glow, no? Tell me like which bulb will have more intensity. So the intensity of bulb depends on what? Let me introduce here only all the ideas so that will be easy for you. There's a bulb B1, bulb B2 that is having resistance R1 and R2. Now, the brightness of bulb brightness of bulb or intensity of light emitted by bulb. Depends on what? Uh, depends on power, electric power dissipated, or directly proportional with light. Bulb is directly proportional to electric power dissipated across it. I'm trying to cover the bulb idea here only rather than going for some separate concept. The resistance only, the resistance of bulb is what? R1, R2. This is some thing you see. So what all we just discussed, no, that one I'm trying to conclude here. So the intensity or the brightness of bulb depends on what? The power dissipated. I think it's quite clear, no? 100-watt bulb, 20-watt bulb. Tell me which will be give more brightness, the one which is having more wattage, no? So the and P1, P2. So the brightness of the bulb depends on what? Depends upon the power dissipated across the bulb. And let's come for power. Both are having same current, no? The current flowing through each bulb is same. The same current flows. Tell me like the one which is having more resistance is said to dissipate more power, then the brightness of that bulb will be more. Agree this? This will be if R1 greater than R2. Then same current is flowing. So then P1 will be greater than P2. Then which will be more bright? The bulb B1 will be more brighter than B2. Brighter in the sense will emit more light. Brightness of bulb is directly proportional to electric power dissipated across it. Further, as they are in series, no. So what we can say, P1 greater than P2 as R1 greater than R2. If R1 greater than R2, P1 will be greater than P2. Let me put a condition. Nearby diagram, I'll write it. Then P1 greater than P2. What do you mean by P1, P2? Brightness of bulb B1 will be greater than B. B indicates brightness here. So this about when they are in series, no, like this we do comparison. So how to say that the bulbs or the conductors or the resistors they are in series? If the